Hello and welcome back. Today we're solving a geometry puzzle that combines triangles, squares, and some clever mathematical thinking. We have an isosceles triangle with the base of 6 and the legs of 5. Then, inside the triangle, we inscribe a square, so that one side of our square is touching the left leg of the isosceles triangle, and the other two vertices are touching the right leg and the base of the triangle. The question is, can we calculate the area of this red square? If you want to answer this question for yourself, you can pause the video right now and then come back to check the solution. So we're going to start by labeling all the vertices of our triangle as A, B, and C. Then we will draw the height from the apex at point C, and we will label its intersection with the base as D. Here, notice the fact that this height touches the bottom vertex of the square. Now let's calculate this height. We're going to do this by taking a look at triangle ADC. We know that the height of the isosceles triangle divides the base into two identical segments. Since AB is equal to 6, this means AD must be equal to 3. We notice that this triangle is a right triangle with the hypotenuse of 5 and the legs of 3 and 4. If you are a newcomer to mathematics, you can always use the Pythagorean theorem to find this height, and I will leave the complete solution on the right if you want to pause the video and check it out. Okay, now let's continue by taking a look at our isosceles triangle ABC. We now draw the height from vertex B down to the left leg, and we label this intersection as E. Now we know that the area of the triangle is equal to the product of the base and height divided by 2. So in our case, this is AB times CD over 2. But we can also get the area as the product of the leg AC and the height BE. So we're just going to substitute the values. Then, by simplification, we get 24 equal 5 times BE, which means that the height BE is equal to 24 over 5. Now, let's label all the vertices of our square as P, Q, M, and N. Now, let's label the intersection between the lines EB and QM as O. And finally, let's label the sides of our square as S. Now, here we use an interesting property of angles in parallel lines, which states that if we have two parallel lines and we draw another line through those lines, which is actually called a transversal, then we can say that each pair of corresponding angles on the same side of the intersecting transversal are equal to each other. So, by taking a look at the angle at point A and the angle at point Q, we notice that those two angles have the same properties, because the lines AN and QM are parallel to each other, since the lines PN and QM are actually the sides of the square. In this case, the line AB will represent the transversal line, so these two angles must be congruent. With this in mind, let's take a look at triangle ABC and we isolate it. Now take a look at triangle QBM and isolate them as well. Can you notice that both of these triangles share a common angle at point B? So, since those two triangles have two congruent angles, this means that their third angle must be congruent as well. Therefore, those two triangles must be similar triangles. Now we use the rule of similarity, which states that the ratio between the sides must be equal to the ratio between their heights. Now let's have a look at the line OB. Since we know that the line EO is equal to S, we can calculate the length of the line OB as the difference between the height EB and the line EO. So since we already have the height EB, so just substitute those values. Notice that we have the length of the line AC, which is equal to 5. Also, we know that the line QM is equal to the side of the square, so we can label it as S. Then we're just going to substitute all those values back into our previous equation, and by doing so, we will get the following relationship. Now, by cross-multiplying this, and then we can simplify by multiplying both sides by 5 to eliminate the fraction, and we will get that 120 equals 49s. 120 equals 49s, which means that the side of our square is equal to 120 over 49. Now, it's pretty easy to find the area of the square. Since the area is equal to the side squared, we're just going to substitute the value for our side. And by squaring everything, we will get that this is equal to 14,400 over 2001. By simplification, it equal approximate to 6 square units. And that is our solution. I hope you found this video helpful. If you did, please like and subscribe to our channel for more. Thanks, and good luck.